Now, when we have chemical reactions with organic chemistry, we have two main types of reactions. The first one is addition. So what do you understand underneath the term addition? We add something. So you will find that addition reactions only happen with two types of organic molecules. These are your alkynes and your alkenes. Why do they only happen with alkynes and alkenes? Because they are the only ones that have open orbitals on some of their carbons. So an alkene has double bonds. An alkyne will have triple bonds. So they are the only molecules where something can get added to it. So they're the only one that undergoes addition. Then we have another type of reaction, which is known as substitution. Now, substitution, what do you understand underneath the word substitution? It means something else will take its place. Now, these can happen with nearly all other organic molecules. So, addition reactions only happen between these two. But substitution can happen at nearly all others. An example being, I can take an alkane to an alcohol with certain conditions. And we will be discussing those conditions as well. So, from here we are going to basically be drawing a map to navigate organic chemistry, to see exactly what will happen and where. So, usually in the heart of organic chemistry we have a certain something known as an alkene. So alkenes are at the heart of everything when it comes to organic chemistry. So, what can happen with an alkene? If I add a haloalkane or a hydrogen with bonded with a halogen. So for example, hydrogen bromide. So I will be adding with HX. What is that type of reaction? It is addition. And what will be the new thing that forms afterwards? I will have a haloalkane. Now, what is this type of reaction called? This type of reaction is known as hydro, which is for the hydrogen, and halogenation. So, to get a haloalkane, I will have something will undergo hydrohalogenation. Yeah.
Because it's an alkene becoming a haloalkene, this is not going to be a haloalkene.
No, it's a haloalkane because if we look at the structure of an alkene, for example, let's take ethene as an example. If I take ethene, for example, if I add with hydrogen and a halogen, what will be my new haloalkane? We'll have single bonds carbon, and here will be my halogen, and my hydrogens will add to the rest of them. So since I'm adding with a hydrogen and a halogen, it will break this double bond. So this one will have its own single bond, this one will have its own new single bond. And then all of its orbitals will be filled. Now, from the alkene, there's another addition reaction that can take place. We'll get to working them backwards soon. And this is known as hydration. So if I say hydration, if you want to be hydrated, what do you drink? Water. So if I hydrate an organic compound, I add water. And what do you think will be the thing that forms? Which one has OH with it? What forms? It is an alcohol. Okay, another addition reaction that can take place is hydrogenation. It's in the name. Hydrogenation, which means I add with hydrogens. And what forms if an alkene is saturated with hydrogens? An alkane. Huh? So I think I've got my alkene. They have the two open bonds. If I come here, it will become an alkane. All my hydrogens will be saturated. It adds with the two hydrogens that are missing. And what type of reaction is this once again? All of these reactions in yellow are addition reactions. So I'm just adding to the alkene, just giving it something to work with. Now, we will get to the next type of reactions, which are substitution reactions. So, if I have a substitution reaction, for example, let's say I want to go from an alkane all the way to a haloalkene, alkane to a haloalkane. What will happen? This will be a substitution reaction that is known as halogenation. So in red, I will have my substitution reactions. So this is known as halogenation. Basically, what this means, I add with a double halogen. For example, bromine in diatomic form, chlorine diatomic forms. What do I know? Most of my halogens are what type of molecules? They are diatomic. So since they are diatomic, usually one of them adds to it, and what gets thrown off? From this reaction, I will get a hydrogen bound with a halogen. So what this byproduct that forms from here can once again fuel hydrohalogen. Okay, so this will be the byproduct. This will be what is in excess, what gets thrown off. Keep in mind with all substitution reactions, if you think of a soccer or sport, what happens as soon as you put someone on, someone has to come off. So all of these reactions also work in that sense. As soon as you put something in, something must come out. Okay. Okay. Next one is hydrolysis. So, if I want to go from a haloalkane to an alcohol, there is a reaction that happens which is known as hydrolysis. Now, hydrolysis, what this means is I add with a hydroxide. What is a hydroxide, or an example of a hydroxide? What's the most common one we have? Nope. It is potassium hydroxide. Potassium is a very strong reaction agent, and potassium tends to want to bind with halogens. So keep in mind it's a substitution reaction. So what will be my byproduct? It will be my potassium bound to my halogen. So it will be potassium bromide, potassium iodide. These are names we know as very common. We just don't talk about them that often. Now, this reaction over here from alcohols or from haloalkanes to alcohols can also be reversed. What will I be adding with them? I will be adding once again with a hydrogen halide. Halide. So a hydrogen halide is a hydrogen bound to a halogen. So going forward, I have potassium hydroxide to get an alcohol, and from that alcohol it can also go back to a haloalkane by means of adding a hydrohalogen. Okay. Now we're going to get to the fun types of reactions. We are going to get to the elimination reactions. Now, if it is called, let's use a new color for this. If it is called hydrohalogenation from an alkene to a haloalkane, what will it be called if it goes back? We will call it dehydrohalogenation. So what does that mean? What gets taken out? A hydrogen and a halogen. So it's dehydrohalogenation. So as soon as you see D in front of it, you must know I am taking something out. Okay. For example, if the count is depleted, it's empty, something's been taken out. Nothing. Okay. Now, there are certain conditions for this to happen. So most of these reactions, addition and subtraction, most of them happen at room temperature or under standard conditions. But in order to break something or to eliminate something, what is usually your first thing that gets added? In order to break a bond, we did this in grade 11 and 10. I have to add heat, kinetic energy. So there will be a change in temperature. I add kinetic energy to it. And what else? In this case, it must be dissolved in ethanol. So what also needs to be present for this reaction to take place? Funnily enough, ethanol must be present in order for this reaction to take place. Then, the easiest one, to go from an alcohol back to an alkene. If I go forward, it is hydration. So to go backward, it's dehydration. Now, certain things must also be present in order for this to happen. I must also add heat. Why? Because when I want to break bonds, usually energy is a big factor. And the other thing, what acid is your strongest dehydrating agent? It's not an acid. Salt is not an acid. It's H2SO. Sulfuric acid is your strongest dehydrating agent. What's also needed if I want to create, let's say, an ester? Carboxylic acid. And what? Is something else? So I know there's a carboxylic acid needed. It's already changing from an alcohol to the leak. What also needs to be added to change from an alcohol to an ester? There's one specific thing that needs to be added. That is when we said formation of esters. You also need, what's one of the byproducts when I create an ester?
Oxygen and H2O.
H2O.
Yeah.
What's my strongest dehydrating agent?
H2O.
So what needs to be present when I create an ester? Sulfuric acid. Why? Because what gets thrown off as a byproduct? H2. Okay. Now, then the last one that we get is known as cracking. Now you will see cracking does not form part of the entire cycle. For one specific reason. I get two types of cracking. I get thermal and I get something that is known as catalytic. Now when you think of thermal cracking, what does thermal make you think of? Temperature. So thermal means high heat and also high pressure. In order to create what? Smaller chambers. So cracking will basically split molecules or these large molecules apart in order to create smaller chains. Now what's my last one? It's catalytic. When I say catalytic, what's the first thing you think of? A catalyst. So what gets added? A catalyst is present. Now, what do I know with my reaction theory? If a catalyst is added, what is necessary for the reaction? I need less kinetic energy or enthalpy in order for my reaction to take place. What does a catalyst do? It lowers the reaction energy. Okay. Now, I think we are going to stop there for now. I will add and explain the rest after this one.